And we're live. Welcome to Practical Programming. I'm your host, Mr. Marlowe. This is 4B, and it is October 20th. And today we are talking about functions. So we have a new assignment in Google Classroom, and it's right down here, functions and LED color mixing. So if you want to go ahead and click on that and open that up. And then some things in there. We're going to kind of sort of be doing this similar to what we've done before with one small difference. So you can see here it says number one, we're going to complete the RGB LED color mixing Arduino project, except we're not going to do it like they have on there. We're going to look at it and we're going to use it like a base for what we're doing. But I'm actually going to have you do something completely different that's not in the instructions at all. So you're going to have to follow along with me. And if you're watching the video, you're going to have to follow along with the video, like if you're watching the recorded version. So follow along with the video. If we do, like if you get behind or whatever, remember, as always, you can holler out and say, help, or I need help, or slow down, or whatever, and I'll slow down. If you don't want to do that, like if you're like, oh, I'm totally lost, I don't want to say anything, you can go back and watch the recording later if you want. That way you can pause it, and then you can do it at your own pace if you need a little bit more time. So we have that. So we're going to be doing that thing here. Then instead of like we've normally done, where we just click mark as done, we're actually going to be copying our program from Tinkercad and pasting it in a Google Doc. So right now, if you want to make it easier on yourself, you should have a little button on the top right that says add or create. And you're just going to click on that and you're going to create a Google Doc. And that will make a Google Doc, a blank one that is attached to this assignment. You'll get one, it'll pop open like mine is here. And you can just leave that there and come back to Google Classroom. We'll worry about that later. But for now, if you want to just go ahead and create it so we can use it later, that might make your life a little easier. So once you have that Google Doc created, come on back here, and when we're finished at the end of this assignment, we'll copy our final code and we'll just paste it in there, and that's what we're going to turn in this time. So we're going to talk about functions. So I'm going to do the slideshow presentation first. So I'm going to go ahead and present that. So we're talking about functions. You have a copy of this if you need it. Now I have mentioned functions before, and I've said that Arduinos use lots of functions, and that's what makes them so easy to use, is they've taken lots of different functions and turned them into like just little simple single lines of code versus big long lines of code where you're trying to tell the computer exactly what to do. They've simplified it with lots of functions. So we're going to learn how to create our own functions if we wanted to simplify our code even more. So our objectives for today is to explain what functions are in computer programming. And we need to do this so we can write a basic computer programming using functions, and we'll be successful when we have done that. We're going to write a program today that has a couple of functions in it that we're going to make on our own, and that will be success. So what is a function? If you looked up a function in the dictionary, it's going to say a named modular section of a program that performs a specific task. So the key there is it's a modular section of code. It's a small block of code that can be used multiple times in other places and make sure programming easy. It also does a very specific task. So sometimes in other programming languages, this is called a subroutine or a procedure. In C++ that we've been using, it's called a function. And actually, yeah, it's called a function. And they may also call it a procedure. That picture on the right, you can see, it kind of tells you what a function can do. A function can have an input, but it doesn't have to have an input. But if we said, okay, we're going to input x, some value, some number, whatever, we're going to input that into our function is going to do something with that number. And then it could have an output. It might not, doesn't need to have an output, but it could. And our output is going to be a function of that X or that variable or that number. So for example, if the function was take any number that you have that you put in and multiply it by 2. And we put in a 2. Okay, so we put in a 2, and then the function says, okay, 2 times 2, and the output is going to be 4. So that's just real simple. And then if we had, say we had a program and we had several, we have several times where we might need to multiply a number by 2. Instead of every time writing a line of code that says multiply this number times 2, we could just say function of this number, and we could just, and that way we could simplify the code. So that's basically what a function is. It may have an input, it may have an output, but doesn't have to have either one. If it has an input, we call that a parameter, and if it has an output, we call it a return. All right, so this looks familiar. You've seen this before. It's the flow chart. And I think when we did this, I'm sure when we did this, I told you this is just like a function. Because right here, we have start, then we have our first sequence, our first thing that we do is wash hands, and then we end. But we don't know what's involved in washing hands. That's kind of hidden from us. So if we look in the background, maybe we see this. We see, well, actually, wash hands is a function that includes turning on the water, dispensing soap, and all this stuff right here. So that's kind of how a function works. We define the function somewhere in our program. We say, this is what wash hands is. And then when we actually run the program, we call the function. So it's important that you know calling a function is the first time that we'll say we're going to use it, but defining it is when we're saying, this is what this function does. Now, in this particular case, they've actually kind of made it look like we have a function inside of a function. So this little one here called wash hands till clean, we can say, well, that could be a sub-function, a function inside the function. And it would include this stuff right here. Wash hands till clean, rub hands together. Are they clean? Yes or no? So that's kind of what a function would look like. That's how our program would look like in a flow chart maybe, is we would say, okay, main program, wash hands. So when the program gets down to here and says, okay, what is wash hands? And then it goes and looks for the function called wash hands, and it does what's in here. Then it gets down to here and says, what is wash hands till clean? And then it goes and it looks for that function somewhere else, finds it, and then it continues to do this. And once it's done, it comes back to the end here, and then it goes out and ends. So a function is just little blocks of code that we can reuse. They get reused over and over again. All right, any questions on that? Does that sort of make sense? Okay, so now if I take this flowchart and I put it into the C++ that we've been using, this is what it might look like. So we start out, and usually in C++, your program, the main program that you're running, the main thing, is usually called main. And I put main program on here so you can just kind of see that's what I'm talking about. But so what would happen is when the computer ran this, is it would say, okay, first thing I'm going to look for is main. And then it finds main, and then it says, okay, I'm going to run main. And when it gets inside of main, which is everything inside the curly braces, it says, okay, this is telling me to do this function called wash hands. Then it's going to jump out of here, and it's going to go find the function called wash hands, which is right down here. And it says, okay, I'm going to do that. And it does everything inside the curly braces. So I just put comments. This could be actual lines of code, but it does all those things. And then it gets to this part here, and it says wash hands still clean. So that's another function. So it jumps out of here, and it goes and it finds the other function down here. It does that. Then it comes back up. It finishes wash hands, and then it jumps back out of there and comes back up to the main program. And in our case, that's the only thing in our main program. But let's say we could put other things in there. And if anytime we wanted to wash hands, then we could just go back and type wash hands. We don't have to type this whole thing down here again. We can just type this one line anytime we want to wash hands. So that's how it speeds up your coding and makes it more compact and such. So we just have to say, okay, I'm going to use wash hands multiple times a day, hopefully. And then anytime I need to use it, I'll just type wash hands instead of do all this stuff here every time. Now, hopefully that makes sense. If it doesn't, let me know in the chat, or you can unmute your mic if you want. So the next thing If we took that same idea and put this into our blink LED, this is one of the first things we did with the Arduino, where we said, okay, we have a setup, and that's actually a function, and we set up our pins, and then we have our loop. That's our main function in an Arduino, is the loop. And then we have this other function called blink LED. So once it gets to here, this is my own personal defined function called blink LED. And down here, I would put that code that we used to turn the pins to high and low, to turn the LED on and off. I put that in there. Then anytime I want to blink the LED, all I have to do is type this one little line of code right here, blink LED. And then it will do all this stuff in here. So that it's a way to kind of simplify it. So that's what we're going to do today. We're actually going to look at one slightly different code, and we're going to take what's in the loop, move it into a function. All right, so this next thing, this is kind of getting a little crazy with it, but I just wanted to show you how you could use parameters and returns. So this could also be run in an Arduino. This is just a program that adds things together. So it adds two numbers together. So I start off with my setup, and I did something here with a function called serial, and this is serial.begin, and I'm going to tell you what that is later. But that's basically a serial monitor, which lets you see what the Arduino is thinking. So all of those numbers and the voltages that are coming out of those pins, you can actually see what's coming out of those pins by using this serial.begin. And I'll explain that later at the end. And then we go into our loop and we set up 3 integers, one of them called x, one of them called y, and one called sum. We say that x is equal to 1, y it gets the value of 2, I should say. And then we say sum is equal to the add stuff function using x and y. So what it does, once it gets here, it says, well, what is add stuff? And then it jumps down to here. Now you notice here I didn't write void because my function is taking in a parameter as an integer and it's putting out a result as an integer. So I can't put void, I have to say int. Then there's my function, add stuff. So if you notice here, I'm sending it 2 values, the first one and the second one. So what it does is the first one, it assigns the value of A, and then this one it assigns to B, and then it makes a new integer called result, and then it says result is equal to A plus B, which in our case is going to be whatever is in x and y up here, and then it returns the result as result. So it returns that number. So in my case, I got 2 and 1, so 2 and 1 would come in here, and this would be 2 plus 1, result would be equal to 3, and then it would return a 3. So in my case here, sum would be equal to a function of x and y, or add stuff x and y, so sum would be equal to 3. And now in this next one, it would actually print the number 3, because sum will be equal to 3 by now, and it will print that out. And I'll show you later on where it prints that out on the Arduino. Okay, so any questions? This last one, you don't have to like get all in that. You just have to kind of know that we can do weird stuff with it. So anybody have any questions on that, how that works? You can put it in the chat. You can unmute your mic if you want. Okay, so feel free to question away if you want. I'm going to go ahead and escape out of this. And I'm going to go back into this thing here, my Google Classroom assignment. Now, the Tinkercad project that we're going to use is, you can go to this link. Now for this one, it doesn't matter, I don't care which way you're logged in, whether you have your own login or you have the classroom, because I'm not even going to look at this one. I'm just going to look at the code that you're going to copy and put in Google Classroom. So in this case, if you just want to click on the link, it should take you to this page. If it asks you to log in because you're not logged in, you can use your username and password as before, or your username from before, your nickname, the class code. I'm going to stick that in the chat just in case it asks for a class code. So you can see that there. So there's the class code there in the chat if it asks for one, but you don't, I mean, however you need to get in, that's fine, as long as you can get to this page. And then you can get to this one. We've been here before, we've done the blinking LED. So once we're here, what we're going to do is we're going to go over to this one on the far right, the RGB LED color mixing. So everybody go ahead and go to that one. If you're not there, let me know. I'll wait for a second or two, and then I will jump in there. If you need me to show you how to get in there again, let me know. But I'm using RGB LED color mixing, the one over here on the far right. So I'm going to go ahead and click on that. And I get this project here. So what I'm going to do real quick, I'm going to reset mine just because I'm not sure if I did it last time I did this one. So let me reset it. Anybody not here yet? RGB LED color mixing. Okay, so it looks like everybody's here. Oh, Ella's not here, Malcolm's not here. Okay, how did I get there again? Ty says, okay, so all I did was I was in Google Classroom and I clicked on this link where it says learn how to use Tinkercad. Hopefully it opens up this page. If it doesn't, if it asks you to log in or something like that, then just come back to Google Classroom and click on the join class link up here and put in your username or your nickname, your first name, last initial, same as before. Then come back and try to click this link. So you're here. And then this particular one, it's on the same page. You don't have to do anything. It's right there. It's on the far right. So Ella, Malcolm, Ty, let me know in the chat when you're there. Just say I'm there or got it or here or whatever. Ella's ready. Excellent. Ty, Malcolm, are we there yet? Are we there yet? Are we there yet? Ty's ready. All right, Malcolm, just you, buddy.
I'm good.
All right, Malcolm's good. Okay, so we're all in this thing here, and this is real simple. It kind of looks hard because they put it on a breadboard, but if we look at it, I'm just going to follow through here. You don't have to do anything to this circuit. We're not actually going to do any circuits. It's going to be all programming today. So I've got ground, and I got 5 volt. It's going to my breadboard. Okay, plus my positive and negative rails. It jumps over to the other side, positive and negative rails. And up here on the top, I've got a tricolor LED or an RGB LED, which is for red, green, and blue. So a tricolor LED, we've used them before. They have 3 colors, and we can turn them all on individually or all together. So if I zoom in on that, you can see I've got the first pin is the red LED or the red anode. The second pin is the cathode or the negative side. And you can see they have it going up here into the negative rail, which is good. Then the third pin is the blue anode. And then the fourth pin is the green anode. All right. So so we got the cathode that's going to negative, and then each of the anodes, the red, blue, and green, are going to the resistors. And then from there, let me move down here. Oops. Move down here a little bit. I'm dragging it all over the place. Then from there, the red wire, or the red anode, is going into pin 11. The blue one, now they cross wires here, which kind of annoys me, but the blue one is going to pin 9, and the green one is going to pin 10. So I'm using pins 9, 10, and 11 for those 3 colors. Each color has its own pin. Okay? So that's all there is to it. Now, if I click this right now, and I say start, you can go ahead and do that. Click start. You can see what it's doing is it's blinking between red and a yellowish color. So between red and yellow. So you might look at that and say, well, that's odd because there's no yellow LED. How did they get yellow? Well, what they did was they combined these three colors some way to get yellow. So we can, in addition to turning them on, we can also change the intensity that they're on. So we can either turn red all the way up, or we can turn it part way up. And the same goes with blue or green. They can all change, and we can change that intensity. And by changing that, we can mix the colors and get whatever color we want out of those three colors. So, so that's what they did, is they mixed the colors together. Now, what I want to do is I want to look at the code for that. So what I want you to do, anybody have any questions on that so far before I go to the code? Everybody sort of understand how that works? Okay, so I want to click on code. Make sure that you stop your simulation. If you have a problem, I noticed in the last class there were some people having problems. They said, oh, I can't get this to work. And that's because they didn't stop their simulation. You got to make sure you stop that simulation before you make any changes to it. It won't let you make changes. So I've stopped my simulation. And then I want to click on up here on the top where it says code. We've been there before. And by default, it's going to show me those darn blocks again. So I'm going to change blocks to text by using the drop down. And I want to say, yes, I want to continue. I'm sure I hate those blocks. And they're actually, and I keep saying I hate those blocks, but there are actually some blocks that are good. If those of you who are going to be here for next quarter, when we do mobile apps, we're going to do mostly blocks. But the way they do the blocks is much better than the way that the Tinkercad, much better than the way Tinkercad does it. So anyway, so here we are in text. So we're in text here. Yes, Molly would prefer not to do the text. Now I'll say that we will use some text, but it's mostly blocks because the program that we're using next quarter is much easier to work with. This one's a little bit hard, but once you kind of figure it out, it's kind of easy. Okay, so what I'm going to do is I'm going to go line by line through this code. And I want you to just look at your code and just follow along with me. So first I'm going to look at line 1. Is it Scratch? Amaya says, no, it is not Scratch. It's like Scratch. But it's almost exactly like Scratch, actually. Sort of almost exactly like it. And I like Scratch. Scratch is a good block. It's just a good block programming language. But this one is not. This one's funky. Okay, so anyway, so line 1, I've got my first function, and I'm defining the function here because, am I defining it? Yeah, I'm defining it. On line 1, it says void, which tells me that my function doesn't take in any parameters and it doesn't return any values. It just does something. So that's what the void means. It means that the function just does something. Now, when I'm defining the function, it says setup, and I've got 2 empty parentheses, which means I'm not taking in any parameters. If that's empty, there are no parameters. And then I've got line 2 has an opening curly brace. Now, I want to point that out, that's a curly brace, and that's a special character on your keyboard. I noticed in the last class there were 2 kids who were using parentheses there. Don't use parentheses. They mean different things. Parentheses are for where you put parameters, and curly braces are where you put stuff that you wanted to do. So I have an opening curly brace, and one thing that you should get in the habit of doing is if you find an opening curly brace, look for the closing one, because they go together. So our opening one is on 2, and our closing one for setup is on 6, on line 6. So the program, oops, and I just moved it, darn it. Okay, so our program actually does everything inside the curly braces, which is 3 lines of code, line 3, 4, and 5. It first does pin mode, which itself is a function, believe it or not, and it does that to 11. It makes it an output. It does the pin mode to 10, makes it an output, and it does the pin mode to 9, makes it an output. And notice at the end of each of those commands, I have a semicolon. That's got to be there anytime we call a function. So in that case, we're actually calling 3 functions called pin mode, calling it 3 times on 3 different pins. So then so that's the end of my setup. Now I go to line 8, and now I have a function called loop. And in Arduino, this is the main function. This is where all our programming goes, like we've said before. And on line 9, I have an opening curly brace, and its partner curly brace is on line 18. So it opens on 9, it closes on line 18. All right? So pay close attention to that. Closes on line 18. So it's going to do everything inside the loop. Now what it's doing is on lines 10, 11, and 12, it's turning the 3 pins to 3 different colors. And so analog write is a function that turns the LED on. The first parameter is 11, which is the pin that's on, I'm looking at line 10, analog write, pin 11. The second parameter after the comma, that number 255, that's the intensity of the light. So in this case, I'm telling it to turn pin 11 to 255 intensity, which happens to be the maximum number that I can put in there. It goes from 0 to 255. So if we look what pin 11 is the red LED. And it's got a red wire. If we trace that back, you can see it's going to the red anode. So then the next line of code, line 11, is turning pin 10, which is the green LED, to 0, or basically it's turning it off. And if we look at line 12, it's turning pin 9 off. So those first 3 lines of code, those first 3 analog writes on 11, 10, and 9, turn on red, off blue, off green. And it does all of those things, even though they're in sequential order, and it does them in sequential order. It does them so fast you can't see it happen. So it does that, turns red on, green off, blue off. Then it comes down here to delay. So line 13 is delay, and it's delaying, which means it's keeping those things on for 1 second or 1,000 milliseconds. Then lines 14, 15, and 16, we're taking those 3 pins and we're changing the intensity of the color. So for line 14 on pin 11, we are using or leaving it at 255. So we're leaving it at maximum red. But we're also taking 10, which is green, and we're leaving it on maximum green. And then on pin 9, which is in line 16 of our code, we're turning it from 0 up to a 102, which is roughly almost halfway on. So it's half on, half off. And those 3 numbers together, when we turn those 3 lights on with those 3 intensities, that's what gives us our yellow color. So what you can do, if you'd like, is you can see that those numbers that are the 255s, the 102s, the zeros, you can change those to whatever you want. Anything between 0 and 255. So you can do all of them if you want. You can change one of them. So let's say on the void loop on line 11, if I change 0, and let's say I change it to 100. And then on line 16, line 15, pin 10, on the bottom half of it, I'll change that from 255 to 100. And then I hit start simulation. And now I've got an orange and a pink. So 255, 100, 0 on the top 3 gives me orange, and 255, 100, 102 gives me that pinkish color. So that's how we change the color. So we change those ending values. Anybody have any questions on how to change the color?
Yeah.
What's up, Malcolm?
Never mind.
You got it?
Yeah.
Okay. So if you want to change it again, you have to hit stop simulation first, because it won't let you change it when it's running. So let me just go ahead. I'm going to change it a couple more times. I'm going to make this first one 255, 100, 100. And then the next one I'm going to do 255, 0, 100. See what that does. Now I get pink and like a purplish color. Okay. All right. So we know how to change colors. We can make that LED turn whatever color we want by changing those three values on the analog right. We're changing the intensity of those three colors anywhere between 0 and 255. Okay, so now it's going to get complicated. Now we're going to make our own functions. And what I want to do is, let's say I want to use the colors more than once. And I don't want to have to copy 3 lines of code every time I want pink. So right there you can see my first one is pink and my second one's purple. So I don't want to change it. I want to write 3 lines every time I want to get pink. So I'm going to make a function called pink that's going to run those 3 lines of code. Okay? So the first thing I need to do is I need to define a function. So what I want to do is outside of the loop, so outside of my loop function, after line 18, so that little closing curly braces, make sure you don't lose that because you need that there. I'm going to hit enter a couple times and give me some more lines down there. And this is where I'm going to put my functions. So down here in the bottom, after loop. Before I do that, I'm going to take my code in loop and I'm going to break it up into 3 parts, or maybe 4 parts, I guess. So I've got these first 3 lines, the 3 analog writes. That gives me my pink color. Then I have a delay for a second. Then the next 3 lines, that gives me my purple color. And then I have another delay. Okay, so you see how I've broken that into 3, so those parts. I have one part. This is going to be my first function. I have another thing, this delay. I'm going to leave that there. And then I have my other part, my 3 analog writes. That's what gives me my purple. And I'm going to use that for my function. And then the last one is another delay. I'm going to leave that there. So let me go ahead and start my function. I'll start my first one, and I'm going to call it pink because that's my first color up here. That's pink. So down here on the bottom, I'm going to type void because I'm making a new function that doesn't return any values, doesn't return like X's and Y's and stuff like that. And I'm going to call it pink. So you can call this whatever you want. And then after the function, I'm going to put my parentheses, open and close parentheses. And there's nothing in there because it's not taking any function, but those have to be there. And now everything that is in my function has to go inside a pair of curly braces. So I'm going to hit enter one time, and I'm going to type an opening curly brace. And it should automatically drop it right below the void. And then I'm going to hit enter 2 times, and I'm going to do a closing curly brace. So all of my stuff has to be inside of those curly braces. So everything that turns that light pink needs to go inside of the curly braces. Now what I'm going to do is I'm going to cut it out of here. Rather than try to retype that, I'm just going to cut it. And hopefully you know that if you push Control and X on your keyboard at the same time, it will cut anything that you select, which means it has taken it out of there and put it on your clipboard. So I have those 3 lines that I want selected. My analog write for 11, 10, and 9, and I push Control C on my keyboard. Or no, sorry, push Control X. Control C is just copy. I'm going to Control X, which will get rid of it for me. And then I'm going to come down to my void function inside the curly braces. And I'm going to push Control V as in Victor, and that's paste. So now I'm just going to straighten these up a little bit because I've got a couple extra little spaces in there. But right now, so now I have this function called void pink, and inside the curly braces, it's doing 3 things. It's turning pins 11, 10, and 9 on at different intensities. And that's it. So I've defined my function. First thing is I've defined the function, said, this is what pink is. Now, right now, it wouldn't turn, nothing would turn pink because I haven't called my function yet. So inside the loop, where I just got rid of that stuff a minute ago, I'm going to call my function. And the way I'm going to do that is somewhere in that blank space that I just cut that stuff out of. I'm going to call the function by just writing pink, open and close, parentheses, semicolon. And that's all I need to write to type. Anytime I want to call that function, I just type the name of the function, my open and close parentheses, and now I have to put a semicolon. When you're defining the function, you don't need a semicolon there, but when I call it, I do, because now it's a command. I'm not defining it anymore. So everybody see how, anybody not understand what just happened there? If you're kind of stuck, let me know, because I'm gonna do the same thing again with these three lines of code on the bottom, inside of the bottom of my loop. You can unmute yourself, or you can put it in the chat if you have a question. Okay, so now I'm going to do the same thing. My second color was purple, I think. So what I'm going to do is below pink, I'm going to come down here, give another couple spaces. I'm going to do the exact same thing. Void, except this time I want to call it purple. P-U-R-P-L-E. Open and close parentheses. Enter. Open curly braces. Enter twice. Close curly braces. So on that little line that's left over, that's where I'm going to take these 3 lines of code, my 3 analog writes, the second ones, the ones that gave me purple. I'm going to cut those, Control X, paste them into my purple function, Control V, get my line straightened up there. Okay, so I got 2 functions I made. One's called pink, one's called purple. And inside my loop, which is my main program, I've called pink 1 time, then I delayed for 1 millisecond, or sorry, 1,000 milliseconds, 1 second. And now down here in my empty space, I'm going to call purple. So I'm just going to do purple, open, close, parentheses, semicolon. And then I need to have this delay down here. I need to have that delay. If you don't have that delay, then it's going to switch from purple to pink so fast, you won't even see it. And it will just stay one color. It'll just stay, I think it'll stay pink. Yeah, it'll stay pink for 1 second. And then it will jump back to pink really quickly. All right, anybody have any questions on what I just did there? Okay, so just to review this, let's see, we got 5 minutes. I wish we had more time. I kind of went slow through that because the last class had so much trouble with it. But anyway, I got my function called void set up. I got a function called loop. And inside that function called loop, I'm running 2 functions, one called pink and one called purple. Down at the bottom, below loop, I've defined my pink function and I've defined my purple function. Now, if I hit start simulation, you can see there it is. It's working just like I said it would. It's turning from pink to purple. Because what it's doing is it's running everything in the loop, and every time it gets to this pink function, it calls pink, and every time it gets to purple, it calls purple. So that's all a function is. That's how you define a function. That's how you call a function in C++. Anyone have any questions on that? All right, so here's what I want you to do. I'm going to take my code. I'm going to select all of it and copy the whole thing. Push Control C on my keyboard, not cut, Control C. Then I'm going to go back to this blank document that I had, and I'm going to push Control V, as in Victor, and paste it. So now you can see I took my code, I copied it into Docs or Google Docs, and then I'm going to turn it in. I think you might have a button up here at the top right somewhere that says turn in. If you have that, you can just click turn in and then you're done. If it's not there, remember that this saves automatically, so you can just close that and go into the assignment, the functions and LED color mixing, and then click turn in there. One or the other, it doesn't, however, whichever one it lets you do. But that's all you're turning in is the code. All right, anybody have any questions on that? Now I have 3 minutes left, and I want to give you a kind of a sort of a little tiny bit of homework. Because earlier I told you I'd tell you what the serial print and the serial monitor was, but we haven't had, we didn't get a chance to get to that because I went kind of slow through that. I want to make sure everybody got it. So what I'd like you to do for a little bit of homework is, if we go back to where we were before, so we were back here, we clicked on the link in Google Classroom, learn how to use Tinkercad. We got to right here. We did this RGB. Well, I want you to come down here to show all Arduino and click on that. And we've been here before. Last week we did potentiometer and push button, so we did those two. What I want you to look at for your homework, and this should only take you like a couple of minutes, you could probably do it before class is over, is click on this using a serial monitor. Using the serial monitor. And you don't have to do anything here, you don't have to turn anything in, but what I want you to do is I want you to just look at the code on these two Arduinos, 1 and 2, and look at the text code. Don't look at the blocks, look at the text. And you notice when I click, they're a little different. But basically, what's happening here when I hit start simulation, so they're running, and right now nothing's happening. But let's see, I'm on Arduino 1. If I come down to the bottom here and I click serial monitor, you can see like there's a bunch of zeros there. And it looks like they're just sitting there, but actually they're moving. But they're moving so fast we can't see them move. If I come up to the button and I push the button, it changes to ones. Every time I push the button, I get a 1. Every time I let go of the button, I get a 0. So that's what the serial monitor does. It lets me see what value is coming in to that pin. What value is coming into pin 2. And because it's digital, it's either going to be a 0 or a 1. Now, if I come down here to the potentiometer, that's an analog signal. So it's going to give me a range of numbers. And if I start clicking around on the potentiometer, you can see the number increases the more I turn it to the left, and decreases the more I turn it to the right. Why am I getting the 266? Okay, so what that number means, is that's the millivolts coming out of that pin. So right now, mine, right now I got 225, there's 266 right there. That just means there are 266 millivolts coming out of the wiper pin into A0. Okay, now the reason why we might need to know that is if we were designing a circuit or something and we needed to know, we wanted to do something once it got to a certain number. Oh yeah, so if you didn't get 0, to get 0 on this one, you have to turn it all the way to the right. And I think you can get 0. But now we can actually use that number to help us with our program. So if we wanted to know, well, how do I get a 5? What do I do if I get 500? If we say we turn it up and it gets higher than 500, we want it to turn something else on. So that's how we would do it. We'd say, okay, if I turn it halfway, I'm getting 511. Halfway is 500 or so. So if it goes past halfway, then I know it's above 500. So that's just what that's for. And if you wanted to, you can kind of look and see how they do that. They use that serial.begin in order to turn on the serial monitor, and then they use serial print line to print that value down here in the monitor. All right, so that's all I got for you guys. Make sure that you have turned in your code Yeah, I just wanted you to look at it. You don't have to do anything with it. Just take a look at it, and then we'll do something with it next time. So make sure you turned in that code in Google Classroom. It's on a Google Doc. If you had any questions, I'll stick around for a little while after. If you had any questions or you didn't get it finished or whatever. But that's all I got for you. I'll see you folks on Friday. Yes, click done or click turn in or whatever it says. Oh, you mean on this one? On the that one, the serial monitor? Yeah, you can click done if you want. I just want you to take a look at it. On this one, LED color mixing, you can click done if you want. But the only thing I need the code in a Google Doc, just like this. And then I'll stick around for a few minutes till everyone leaves in case anyone has any questions. Can you explain what we have to do? Homework? Michaela, I just wanted you to look at just that one thing, the one that said, this one right here. Just to look at it using the serial monitor. And it was, it just take you a minute. It's, to get to it, if you go to the Google Classroom, click on Learn How to Use Tinkercad, click on Show All Arduino, and it's right below the LED one, using the serial monitor. So I click on there. I get this thing here. It's got two different Arduinos. We've done both of these before. We've done the potentiometer and we've done the push button. And if I hit start, now and then I got to click on code. Click on code. No, you don't have to do anything. I just wanted to look at it just so you can see how that works. And because we're going to use that later on. We'll come up with a way to use it. No problem. Mason, are you really there or are you goofing off? Mason. 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 I think Mason's goofing off. He turned in an assignment with nothing on it. Mason, I'm returning that to you with no grade on it.